Welcome to Young Asia Television.
Presented by the National Science Foundation of Sri Lanka.
Welcome, and we're ready to start Mihi Mandala. Today on Mihi Mandala, we talk about a scarce resource, without which life on Earth would not be possible.
It falls from the skies, is frozen in glaciers, is found in oceans, stored in lakes and reservoirs, and manifested by underground springs and wells. Water is vital to all life forms on Earth. Water has thus been a powerful element in all historic civilizations. The Mesopotamian civilization, for instance, originated in an area between the Euphrates and Tigris rivers. The Chinese civilization developed in the Yellow River region. The Egyptian civilization emerged in the Nile River Valley. And the Ganges Valley civilization and Mohenjo-daro and Harappa civilizations in India emerged in the Indus Valley.
Water has a central place in religious practices and beliefs too. Many religions, including Buddhists, Muslims, Hindus, and even Christians, perform rituals surrounding water. In fact, these religions believe that water is both sacred and divine. Now that we have understood the many uses of water, both historically and culturally, let's see if we can understand water scientifically.
Water is a transparent liquid substance made of molecules. Each molecule is made up of 3 atoms, 1 oxygen atom and 2 hydrogen atoms. This non-carbonated synthesis is found in liquid state at room temperature because of the hydrogen bonding between water molecules.
Water falls from clouds. It doesn't contain in any minerals or metals, but when they contact with soil, so all this material get into water and the water become rich with minerals. So this mineral concentration and composition of water is depend upon the soil geology of the area where we collect water samples. Then if you take water sample from the Hambantota area and the down south, definitely this water contain lot of calcium and magnesium, and this water is called as hard water. If you collect water sample from Uva area and Anuradhapura and some other part of the country, sometime you can get completely different type of metals in their water. Geology of the area where you collect water sample, it is effect on the quality of water. If we take agricultural area, so the people use lot of fertilizers and some other chemicals to get so the agricultural practices, and the most of plant can't absorb all these chemicals, and they come into soil and seep into groundwater or surface water. So this water contaminated with different type of heavy metals and some other organic and inorganic chemicals. So then we can say all metals and all minerals in water is not essential for human, but some minerals and metals are very essential for human health. So if the water contain mineral and the metals are very high, so this may affect on human health.
Is consumable water a limited or an unlimited resource? And is it spread across the world? Let's find out.
"71% of Earth's surface is covered by water. 97% of the water on Earth is salt water, and only 3% is fresh water. 30.1% of the 3% of fresh water is deposited underground. 68.7% of fresh water is frozen in ice caps and glaciers. 0.3% of consumable surface water is available in lakes, reservoirs and swamps, while 0.9% of fresh water is found in other sources. Water on the globe is not evenly distributed among all regions. Asia, which is home to 60.5% of the world population, accounts for 36% of the global freshwater runoff, while Africa, which houses 14% of the world population, have access to 10% of the global water reserve. Europe, which has 8% of the world's water, is home to 11.3% of the world population. North and Central America have 15% of the world's water and only 7.3% of the world's population. South America and the Caribbean countries, which represent 6.4% of the world population, have access to 26% of the global freshwater reserve, while Oceania, which is home to 0.5% of the world population, accounts for 5% of the Earth's freshwater reserve. Groundwater accounts for 30.1% of the world's freshwater supply. Let's find out at what depth from the Earth's surface is groundwater deposited.
Generally, groundwater could found within 600 to 700 feet below the surface of the Earth. However, usually groundwater could extract from ordinary well or tube well from about 250 feet below the surface.
It is vital to ponder over the importance of groundwater, comparing to other water sources.
I would like to highlight that the groundwater is vital for everyone, because if we go to countryside, the majority of people who live in countryside utilize and consume groundwater in large scale. Furthermore, especially the large quantities of groundwater is utilized by industry and schools. Therefore, the demand of groundwater is very high. So then we observed because of the very limited proportion of surface water is available for these people. So therefore, the people like groundwater for their daily consumption.
It is a natural phenomenon where the water that falls from the sky gets mingled with various ions and minerals. Factors such as rainfall, degradation and soil erosion are all natural pollutants of water. But they are not the main factors. There is a far greater threat that water faces today. Let's find out how water is polluted due to the result of human activity.
The water pollution mainly due to point and non-point sources. The point sources are the place where people intensively and the people put chemical or whatever their waste into water, and we can control the point sources.
When an individual or an industry discharges water containing pollutants to a pipe that in turn may flow to a place containing fresh water, that is called point source water pollution. This source is identifiable and controllable. Non-point source water pollution often results from diffuse sources such as urban roadways, housing, agricultural lands and livestock. Let's find out how well water becomes polluted.
The contamination is depend upon the situation and the type of well. So if you take an open well, so there is a high possibility to get contaminate water from different sources like the animal waste and chemicals. Without safe boundary, I mean safe the well, so this water also can contaminate with different type of contaminants, especially during rainy season. The water can get contaminate with chemicals and also fertilizers and pesticide, and finally what happen, all these chemical mix with water and flow to the well, and finally the particular well become pollute and it is unsuitable for human consumption. The well exposed to extreme sunlight, there is a high possibility to grow particular cyanobacteria, algae or bacteria in the well. As a result, so the cyanobacteria or bacteria produce large number of progeny and they increase their density, and ultimately what happen, all these cyanobacteria or algae can produce different type of chemicals and then water contaminated with these chemicals. If a well situated very close to the sewage pit, when the distance is less than 50 meters, so there is a high possibility to get contaminate the water with organic chemicals and inorganic chemicals and pathogens.
This example demonstrates how well water contamination can occur in a highly urbanized area.
We are now going to examine the quality of groundwater in a densely populated urban area. I am currently at 19th Lane in Grand Pass, Colombo, right next to a very popular bathing well. Actually, if you look at this location, you will notice that we are very close to the Sebastian Canal on one side and the Kittanpawa Canal on the other side. In fact, if you look at the water in this well, it reminds me a lot of the color of the water in the Beira Lake, which is quite scary. And if you also look around, you will notice that it's densely populated and there is a lot of human activity in this area.
We can observe the very clear greenish appearance, the surface as well as the water sample collected, and there is a high possibility to have the cyanobacteria and green algae in this water, and also we detected very low concentration of oxygen. This may due to respiration and degradation of organic matter by bacteria. It is possible because around the well there are some toilet pits, the personal and common toilet pits, and these toilet pits can contaminate the groundwater aquifers, and then there's a high possibility to get all nitrate and phosphate into contaminate to groundwater, and that's why it facilitate the algal growth. So therefore the greenish appearance is the surface water has a very greenish appearance.
Water pollution in agricultural and industrial areas.
I have remarked at the beginning that the water table is the exit below the surface of the earth, and also so the water table contain the water, and this water is utilized for groundwater. The quality of well water is very important. So this well water can contaminate with different sources. Therefore, then if we take the quality of well water is differ from place to place. Actually, this is depend upon the contamination status of the site. So the agricultural land use different type of chemicals, fertilizers and other insecticides for agricultural land, and the plant can absorb the little amount of these chemicals, but the rest is remain in the environment. So this the remaining chemical can get into water and the water contaminate. So therefore, so the agricultural well can get all the contaminants very quickly, because so the chemicals can leach through the soil, and also this chemical can enter into the surface water. Therefore, the most of agricultural wells are highly contaminated with chemicals, organic and pathogenic microbes.
In addition to the above, the pollution of groundwater reserves have intensified by poisonous industrial byproducts being discharged into streams, paddy fields and underground pits. Consequences of this unlawful and unethical practice, which has been going on for years, has now begun to manifest, such as the Rathupaswala issue, which drew headlines. The Rathupaswala water issue, which came to light in the recent past, is an ideal example which clearly demonstrates how groundwater has been contaminated by dumping unrefined industrial byproducts directly into underground pits.
The most of the industry produce wastewater, and also household produce wastewater. So then we have rules and regulation. So when we release the wastewater to the environment, we should treat this water according to the standard given by the authority. But what happens when we release the untreated water to the environment? This water reach to the ground and finally get into the water table. Therefore, the well water, so we utilize this groundwater, and then there is a possibility to get contaminate this groundwater from this industrial discharges. Therefore, we should remember, and we should have a very good practice before we release the industrial waste or the house waste to the environment. We should properly treat this water to avoid the contamination from industries and other activities.
Paddy land reclamation in the Mahargaman Navin area is a perfect example which shows how groundwater is polluted by a non-point source. Paddy land reclamation in the Mahargaman Navin area is a perfect example which shows how the groundwater is contaminated. The improper land reclamation had polluted the drinking water wells, extending to an area of 150 meters. The drinking water wells, located 30 meters away from the land reclamation site, are entirely infested by E. coli bacteria. The contamination has already extended up to 150 meters. According to a survey conducted recently, the Ganguruvila South, Jambugasmulla, Vijayarama and Vattagedara areas have been affected by this long-term unprofessional practice.
I think all we know about the managed solid waste management in Sri Lanka. So we practice two type of solid waste management method. The first one is sanitary landfilling methods, and the other method is open dumping method. We have very limited sanitary landfillings in Sri Lanka. But and also I have to highlight, we don't have proper solid waste management. So therefore the authority or the people use the abandoned paddy field or marshlands to dump their garbage, the solid waste. So then we have to think, so when we dump the solid waste to the abandoned paddy field or marshland, so the water table is very shallow. Therefore, a high possibility to contaminate the water table within very short period from contaminants from the garbage.
According to WHO and SLS drinking water standards, the maximum concentration of nitrate which should be present in drinking water is below 45 milligrams per litre. However, 30 milligrams per litre of nitrate is found in groundwater in the Kalpitia area, where excessive amounts of agrochemicals are used for agricultural practices. In some drinking water wells of the same area, nitrate concentration has exceeded more than 77 milligrams per litre. According to a survey conducted in Jaffna in 2007, 81% of the drinking water wells in the area remain inappropriate for human consumption.
Waterborne disease can be divided into two categories: infectious and non-infectious waterborne diseases. Infectious waterborne diseases are predominantly transmitted through water polluted by microbes and parasites. These are both non-chronic and visible.
Inappropriate sanitary habits and consumption of contaminated water results in waterborne diseases such as diarrhea, cholera, typhoid and guinea worm disease.
Non-infectious waterborne diseases are mainly carried through water polluted by chemicals. These are chronic, difficult to diagnose and control, and can have long-term effects on your system.
Chemicals such as arsenic, fluoride, nitrate, cadmium, lead and mercury cause many types of kidney disease, cancer, miscarriages, lung diseases, infertility, abdominal pain, amnesia and several other health issues which ultimately affect the smooth functioning of lungs, blood circulation, kidneys and intestine.
First of all, I think we should have a very good database regarding water quality in the applied to the Sri Lanka, and also before go to a management plan, then we have to analyze the pollutant and the pollutant sources and the catchment of the water sources. Actually, I know there are a lot of information available in Sri Lanka, but not in order. I think we have to collect all this information regarding water quality, and we have to prepare a very comprehensive database to access scientists. So this is one of the important urgent requirement, and also then we have to develop some very clear management plan and management strategies to control water pollution. At the beginning, actually we have to start it from the grassroots level. Then we have to aware people, especially then we can start this program from school level, and the National Science Foundation has already initiated this program, and now we are doing an awareness program about water and water quality and how water get polluted, and then what are what we have to do to keep our water for future generation.
The strength of a building lies upon its foundation. Water is the foundation for human civilization. Yet inappropriate activities, building strategies and the simple lack of awareness has led to the increased pollution of water. And very often it's for simple and easy economic and political gains. In other words, we're weakening the foundation of our very own existence. Undiagnosed kidney disease spread across the country is one such example. So be attentive. Do what you can to protect and conserve this natural and vital resource. Until we meet again next time on Mihi Mandala, be safe.